the quiz will cover up to the Polar's decomposition that I'm going to cover today. And maybe half of the other after class will be reviewing the differential calculus. So let me just make sure. How many of you have not taken a class and course in calculus? Raise your hand. So if you didn't take any class on the calculus, differentiation and integration, raise your hand. Okay, so that means everybody knows at least how to do differentiation, right? Because the second half of this course will covering the differential equation. So for the case of matrix A given by 11 minus 5 minus 2, 10, this is typical non-Hermitian matrix. That means if you take the dagger of A, it's not the same as A. So A dagger is 11 minus 2 minus 5, 10 is definitely not A, right? It's not Hermitian. But there is a way that we can make this matrix Hermitian by multiplying, define a new matrix. M, which is defined as A dagger multiplied by A. Then this is Hermitian matrix. Let me check. So M is given by 11 minus 2 minus 5, 10 times 11 minus 5 minus 2, 10. So if you multiply them together, 11 square is 121, right? So 121 plus 4 is 125. And this is minus 55 minus 75 minus 75, 125. So this is definitely Hermitian, right? So M dagger is M. It's Hermitian. So eigenvalues. We have calculated eigenvalues and eigenvectors in maybe 2 weeks before, but 2 weeks is kind of the span of time that you don't remember it anymore, right? So let's just try to find out it from the beginning. So M minus lambda I is 125 minus lambda minus 75 minus 75, 125 minus lambda. Okay, so maybe better. So this is 125 minus lambda square minus 75 square. So 125 plus 75 minus lambda, 125 minus 75 minus lambda is 200 minus lambda, 50 minus lambda, right? So therefore, lambda is 50 and 200. They are all positive. And we define the definition of positive matrix that is when eigenvalues are positive. So M is definitely positive matrix. So when M is 50, let's say lambda 1 is 50, how do we find the eigenvector? Say lambda 1 is AB. So m times lambda 1, 125 minus 75 minus 75, 125 AB is same as 50 AB. So we can just solve this equation. 125 A minus 75 B, 50A. So that means A equal to B, right? Maybe second term is same as before. 75A plus 125B is 50B. So from this we have A is equal to B, right? So lambda 1 is A and B, A and A. And we like to normalize this eigenvector such that lambda 1 is equal to 1, right? So A is obviously 1 over square root of 2. Therefore, lambda 1 we can have square root of 2, 1, 1. If I have a tendency to go fast, I told you that the best way to stop is ask me a question, right? Delay the progress. And I think I told you about your preparation for quiz. About 2 pages of cheating sheet, right? For quiz. 2-page A4 size cheating sheet. So cheating sheet in Korean is conning paper, right? So officially conning paper is allowed. Cheating sheet is allowed. But no Kakao Talk, no text. But no text or Kakao Talk. Some students use line, right? Line. You can bring dictionary because all the problems will be written in English. That's for quiz. 그거 올려놨어? 그치? 어디? 온라인 클래스룸. So previous quiz will be posted on the online classroom. How many years? 4 years? For the past 4 years. So basically, the old quiz will look similar. I mean, if you can solve the old previous quiz problem for the last 5 or 4 years, then you will be in a very good shape. So lambda 2 is 200. And let's say eigenvector C and D. So m lambda 2 is 200 lambda 2. So 125 minus 75 minus 75, 125. C and D is 200 C and D. So 125c minus 75d is 200c, or minus 75c plus 125d is 200d. So that means d is minus c, right? So using the same logic as before to make the eigenvector normal, so in order to make lambda 2 is equal to 1, c can be square root of 2, right? So the lambda 2 vector is square root of 2, 1 minus 1. So summarize, when A is given by 11 minus 5 minus 2, 10, M is defined as A dagger A 125 minus 75 minus 75, 125. And eigenvalue and eigenvectors of M are of M given by lambda 1 is 50, eigenvector is 1 over square root of 2, 1, 1. Lambda 2 is 200, lambda 2 is square root of 2, 1 minus 1. So lambda 1 and lambda 2 are positive, right? So both lambda 1 and lambda 2 are positive. So M is positive matrix. So outer product. 1 over 2, 1, 1, 1, 1, 1 is equal to 1 half, 1, 1, 1, 1. Lambda 2, 1 half, 1 minus 1, 1 minus 1, 1 half, 1 minus 1, minus 1, 1, right? So let's try to find out square root of lambda 1, lambda 1, lambda 1, square root of lambda 2, lambda 2, lambda 2, which is square root of 50 over 2, 1, 1, 1, 1, square root of 200, 1 minus 1, minus 1, 1, square root of 2 over 5, 1, 1, 1, 1, square root of 2 over 10, I think, right, 10. 1 minus 1, minus 1, 1. So we can actually combine 5 over square root of 2. Let me see. 3, that is 3, minus 1, minus 1, 3, right? So we can have a common factor 5 over square root of 2. So 1, 1, 1, 1, 2 minus 2 minus 2, 2. So 3, 3, 3. Right? So let's say temporarily we can define m, square root of m, as 5 over square root of 2, 3 minus 1 minus 1, 3. Let's check whether square root of m, if we take a square, it becomes m. So check. Square root of m times square root of m is equal to 25 over 2, right? And 3 minus 1 minus 1, 3. 3 minus 1 minus 1, 3 is 25 over 2. This is what? 3 times 1 is 10. 10, right? And this is minus 6. Minus 6, 10 is equal to 25 times 5 minus 3, 5, which is 125 minus 75 minus 75, 125, which is m. So indeed, when we have the positive eigenvalues, we can define the square root of a matrix, Hermitian matrix. Then we have the following polar decomposition theorem. That is, A is given by U square root of m, with U is some unitary matrix. So we are going to construct U. The question is how to construct U. Then we can show this. So if you understand this polar decomposition, then basically you know almost everything about the linear algebra, including the graduate class. Square root of m is 5 over square root of 2. Try to construct U in the following way. We define, first step, define psi I A times lambda I and construct EI, which is psi I defined by square root of lambda I. So this is called psi, Greek. This is called phi. So most common Greek letters that used in physics, especially quantum physics. So psi and phi. And others, this is called eta. And this is called zeta. And psi. You already know alpha and beta, right? Alpha, beta, gamma, delta, epsilon. Alpha, beta, gamma, delta, epsilon. Sigma, tau, omega, etc. Overall, they have 24 letters. So let's construct psi I and EI. So psi 1, A times lambda 1, which is 11 minus 5 minus 2, 10, square root of 2, 1, 1, which is square root of 2. If you multiply by this, what do you have? 11 minus 5, 6, right? And this minus 2 plus 10 is 8. And EI, square root of lambda, 1 over psi 1, square root of 50, square root of 2 over 1, 6, 8 is 100 is 10, right? 1 over 10, 6, 8, 1 over 5, 3, 4. E1. Psi 2 is maybe I should go a little bit slower. One over 5, 3, 4. Step 2. What is M? Psi 2 is A times lambda 2. So 11 minus 5 minus 2, 10, square root of 2, 1 minus 1, 1 over square root of 2. 11 plus 5 is 16, right? And minus 2 minus 10 is minus 12, right? Minus 2 minus 10 minus 12. So epsilon 2 is divided by 200 over psi 2 is 400 over 16 minus 12 is 1 over 20. 16 minus 12 is 1 over 5, 4 minus 3. So let me check. We have from prev. So we have E1, 1 over 5, 3, 4. E2, 1 over 5, 4 minus 3. And let's check whether E1 and E2 form a orthonormal set. So let's check. E1, E1. What do we have? 1 over 25, 3, 4, 3, 4. 1 over 25 times 3 square plus 4 square is 25 is equal to 1, right? How about E2? E2. 1 over 25, 4 minus 3 is 1 over 25, 16 plus 9, 25 again. So 1. How about E1, E2? 1 over 25, 3, 4, 4 minus 3, which is 0, right? So we found that this E1, E2 form on orthonormal basis, right? So we generated another orthonormal basis. Now we define U in the following way. So are you following the procedure? So we first have a non-Hermitian matrix A, and we form a positive matrix M by multiplying A dagger with A, and then find an eigenvalue and eigenvector with that Hermitian matrix. And from those eigenvectors, we form the new vector psi 1 and psi 2. And by dividing the eigenvalues, we generated a new orthonormal vector E1 and E2. And from this E1 and E2, let's try to form a new matrix. So this is 1 over 5. Check. 4 minus 3. E1 3, 4. We define U as the following way. E1 lambda 1, E2 lambda 2. And let's check whether U is unitary. So U is let's have this. So we have E1, 1 over 5, 3, 4. E2, 1 over 5, 4 minus 3, right? So root to M. 3 minus 1, 3. So let's say E1 lambda 1 plus E2 lambda 2 is 1 over 5, 3, 4, 1 over square root of 2, 1, 1. 1 over 5, 4 minus 3, square root of 2, 1 minus 1. So 5 square root of 2, 3, 4, 3, 4, right? sorry. I think I made the. Three, 4, 1, 1, right? Four minus 3, 1 minus 1. So this is 3, 3, 4, 4 plus 1 over 5 square root of 2, 4 minus 4 minus 3, 3. Double check. 3, 3, 4, 4, right? And 4 minus 4 minus 3, 3. So this is 1 over 5 square root of 2, 7 minus 1, 1, 7. Let's define as u. Then u dagger is 5 square root of 2, 7, 1 minus 1, 7. And u dagger u is 25, 50, 7, 1 minus 1, 7, 7 minus 1, 1, 7, 50, 0, 0, 50. Identity, right? So u is a unitary. So now we have, let you copy. Check. 7 minus 1, 7. M is 5 over square root of 2. Let me check. So we have u, 5 square root of 2, 7 minus 1, 1, 7, right? Square root of m, 2, 3 minus 1 minus 1, 3. And let's check. U square root of m, 5 square root of 2 times square root of 2 over 5, 7 minus 1, 1, 7, 3 minus 1 minus 1, 3 is 1 over 2. Let me check. 21 plus 1 is 22, right? Minus 7 minus 3 is minus 10. 3 minus 7 is 4. Minus 1 plus 21 is 20. 11 minus 5, 2, 10. It's the same as A, right? A was given by 11 minus 5, 2 minus 210. Oh, this is minus. This is minus. So polar decomposition. Any non-Hermitian matrix can be written as the following: U times square root of M. So any questions about? So quiz will be covered up to here. From the first class to here. And maybe you can take a break for 5 minutes and then I'll move the next topic, the differential equation. We are going to move on to the next topic. The differential equation. But just in case somebody hasn't taken the differential and integral calculus, I'm going to have a brief review. Of differential calculus. Function. Probably you learned about function for the first time when you were in middle school. The function is basically you have one or more input and one output. So typical case of function is a vending machine you can find outside of this classroom. Coffee machine, vending machine. So you put some coin or some paper money and 1 cup of coffee come out, right? And you have selection buttons, of course. So you can put one or maybe, I don't know, 1, 2, 3, several coins, or maybe several paper money, but you always get 1 cup of coffee. It never comes out 2 cups of coffee, right? So vending machine is a good example of a function. You input 1 or more like numbers, and you get out 1 output. The function is usually real number to real number, or so we are going to cover only the real number case. and say y is fx. So x is a domain, and R is called range. Range. And somewhere in your life, we learned about continuous function. A function fx is continuous at x equals x0 if and only if fx minus fx0 is less than epsilon for x minus x0 less than delta, epsilon delta plus. This is a basic definition of function. At a certain point, x naught, x0. So the difference between fx and x naught is less than some epsilon whenever x minus x0 is less than delta and both epsilon and delta. So if something like this, this is continuous, right? How about this? Continuous or not? Continuous, right? How about this? It's not continuous. So three cases of functions. The first one is always continuous, right? Second one, even though the slope can change, it is continuous. Third case, obviously not continuous. Oh, for the one student asked me whether you can use engineering calculator. So you can use a calculator, but not function, not program. So calculator is okay, but not the program the function. Because these days, the engineering calculator is so good, you can actually program the determinant and input numbers, right? So in Korea, 엔지니어링 공학 계산 쓸 수 있는데 그 프로그램 펑션은 못 써요. Because 요새 계산기 하도 좋아가지고 디터미넌트 몇 개는 다 계산할 수 있잖아. So most likely quiz problems is determinant. Two by two is too easy, so maybe 3 by 3 and 4 by 4. Probably not 5 by 5. So maybe up to 4 by 4. Find inverse function, inverse matrix. Most likely 3 by 3. 4 by 4, I don't know, depending on the mood. So determinant and inverse matrix. Eigenvalue problem, right? Eigenvectors. Maybe 3 by 3. Spectral theorem. So you use the spectral theorem to calculate a to the 5? A to the 7? Okay, a to the 7. Maybe 2 by 2 or 3 by 3. And polar decomposition. I think that's 2 by 2. I think that maybe those 5 sets of problems will make you busy for clouds. So I think we may need to prepare up to 4 by 4, especially with the development So check the previous quiz and design your own problems. So before I proceed, any questions about quiz? This is a perfectly good time to ask. Okay. All the problem set will be in English, but you can write down in Korean. But English preferable. So first quiz will be usually try to make as easy as possible. Differentiability. This is most important thing. Differentiability. Function fx is differentiable at x equals 0 if exists and also sometimes this is called right side differentiation. This is called the left side differentiation. So for example, how about this function? Whether it is differentiable at x naught. It's continuous, right? But the left side differentiation and the right side differentiation is different. So it's not differentiable. So let's try. So when fx is called x squared, fx plus delta is x plus delta square x squared plus 2 delta x plus delta square, right? So fx plus delta minus fx is x squared plus e 2 delta x plus delta square minus x squared. So this to cancel each other will be 2 delta x plus delta square. So if we divide by this by delta, two delta x plus delta square over delta 2x plus delta. And as delta goes to 0, it becomes 2x, right? So we say dx x squared is 2x. I think you know this well from your high school calculus, right? So this is just a review. I think I mean just summarize which you already know. When fx is x to the cube, you can use the same procedure. Fx plus delta is x plus delta to the cube, x cube 3 delta x square, 3 delta square x, delta cube, right? So if we divide delta by fx plus delta minus f of x is 3 delta x square plus 3 delta square x delta cube by delta is 3x square plus 3 delta x plus delta square. So if you set the limit, delta goes to 0, three x square, right? You can continue. When fx is x to the n, what do we get? You can do the same thing, binomial expansion. X to the delta to the n is x to the n plus n1 delta xn minus 1 and 2 delta square xn minus 2 and n delta n. This is called binomial expansion. 이항전개? Probably you learned about this, right? Binomial expansion. Binomial expansion. So, at the end of the day, we have x plus delta to the n minus x to the n divided by delta. Delta goes to 0. We have n to the x n minus 1 at the end of the day. So we have the following table: x fx dx dfx, and this x is 1, x squared is 2x, x cubed 3x squared, blah blah blah, x to the n, and x n minus 1. You already know this result. Probably you're familiar with this result from the high school days. When fx is 1 over x. Actually, you have done this too in high school. So f x plus delta minus f over x plus delta 1 over x, right? X plus delta x minus delta is minus delta over x plus delta. So delta over f x plus delta minus f over x is minus 1 x plus delta. So if you set x delta goes to 0, x cubed and 1 over x squared. You already have done that in high school, middle school? High school, freshman? Freshman in high school? Most likely you just memorized. No derivation, right? How about an fx 1 over x squared? So f x plus delta minus f over x plus delta square minus x square. So this is x square x plus delta square, x square minus x square plus 2 delta x plus delta square, x square x plus delta square minus 2 delta x minus delta square. So if you divide by delta, what do you get? Delta fx plus delta minus f over x square x plus delta square minus 2x minus delta. So if you set delta goes to 0, we have two over x cubed, right? So we can continue. Of course, you memorize this, but let's make a table. We have fx, dx, dfx. 1 over x, what do you get? Minus 1 over x squared, right? 1 over x squared minus 2 over x cubed. So we can continue. 1 over x to the n minus n to the x to the n plus 1. Blah, 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 blah. Basically, you can derive this. And you know this already, right? Now, tricky case. I'll just let you copy. When fx is called square root of x, I think you have memorized this too, right? But let's go back to about 300 years. 1645, Isaac Newton. He was studying the empirical formula. When delta is very small, 1 plus delta square is 1 plus 2 delta, right? One plus delta to the cube, 1 plus 3 delta. When delta is extremely small, you can ignore the square of delta or cube of delta, right? So using that logic, Newton assumed that 1 plus delta to the 1/2 will be close to 1 plus delta over 2. Or 1 plus delta over 1 over n, 1 over delta over n. Of course, 1 plus delta to the n, 1 plus n delta. So Newton discovered that about 200 years ago, that the square root of 1 plus delta is roughly 1 plus delta over 2. So anybody has a calculator, engineering calculator, you can calculate 1 plus delta is 0.1, what do you get? 1.1 square root. 1.05. Let me check. One point one square root. It's roughly 1.05, right? 1.4 something? 48. And delta is small, like 1.01 to the square root. It's even closer. 1.4, 1.049 or something. One 1.01. 1.0449 something, right? So as delta goes to 0, the result is getting close to 1 point delta over 2. So this formula is very convenient if you can remember this. So you can actually calculate many square root by just using memory, by rote. So that's one of the great discovery of Newton in 300 years ago. So using this, we can calculate the square root x. For example, so let's calculate square root of x plus delta minus square root of x is, you can take square root of x 1 plus delta over x, right? Minus square root of x. And that's square root of x times 1 plus delta over x, 1/2 minus square root of x, right? This is roughly square root of x 1 plus 2x over delta minus square root of x is 2x over x delta, 2x delta. So if we divide by delta, one over 2 square root of x, right? So maybe in high school you just memorized. But if you know that the Isaac Newton's the simpler formula, then you can actually derive this formula. So we covered the polynomial and square root x, sine, cosine. So I think you have learned about the addition theorem for trigonometry. 합법 정리. Sine A plus B is equal something, right? Koksa. So for example, sine A plus B, sine A, cosine B, cosine A, sine B. I think you have learned this in middle school. High school? Junior and middle? The first freshman in high school? What comes to? Maybe freshman in high school. Sophomore? Maybe there is a change of the education system. I think I remember I learned in middle school, the third year, junior in middle school. They changed the curriculum every maybe few years. So I don't know, my memory is not quite clear yet, but either the junior in middle school or freshman in high school, we learned about this Sasakusa theorem. Cosine A plus B is cosine A, cosine B minus sine A, sine B. So let's assume that you know this already. Maybe you can actually prove that using drawing of some triangles and etc. But let's just accept this as a truth. This is trigonometric addition formula. Let's draw a circle with the radius 1. Let's say this is theta. This is called arc. Arc is 호, and 편 is called short. What is the length of this arc? Theta, right? Probably you learned in middle school. So what is the total length of circumference? 원주의 길이 2파이, right? So total length of the circumference is 2 pi r, right? When the radius is r, the total length of the circumference is 2 pi r, right? So in this case, the radius is 1, so it's actually 2 pi. So this length, the arc length, will be 2 pi times 2 pi over theta, right? Okay, so what is the total angle? 2 pi, right? And this is theta. So the ratio of this angle is theta divided by 2 pi. And the total circumference length is 2 pi. So this length must be proportional to this angle. So theta, right? So let's draw okay, I will explain in Korean. Seems like some of you might study. 이거 전체 각도 나오네. 2파이. 이거 세타라고 하면은 전체 비율로 치면은 2파이 세타분의 2파이분의 세타잖아요. 반지 중에 1인 경우에 전체 이 원주의 길이는 2파이. 그러니까 이 호의 비율은 전체 분의 이거의 길이는 세타분의 2파이니까 2파이 곱해주면 세타 나와요. So the length of this arc is theta when this angle is theta. Okay. Understood? My French is not good enough to explain this, so I just explain in English and Korean. So the similarity between math and art is you need to draw well. 그린다, 보스. 수학하고 미술의 공통점은 그린다. All right. So let's draw this again. So I'm going to, this is length is 1. Let's say this is delta. Then this arc length is delta, right? And then you can actually draw a tangent line and assume then this is delta 2. If delta is small enough, the length of tangent is also will be the same as delta. Then this length will be square root of 1 plus delta square, right? So I made another approximation that if delta is small enough, then the length of tangent is the same as the length of the arc, say delta. But then this length will be 1 plus delta square, right? Because this is the orthogonal triangle. So cosine delta will be square root of 1 plus delta square over 1. Sine delta will be delta divided by 1 plus delta square. So I'm also following Isaac Newton. He did this in 1645. Isaac Newton. So he basically set up the calculus about 300 years ago by himself. But there was a rumor that actually he had a document from the Greek about 2,000 years before that, Pythagoras time. There was a rumor that they always had a calculus already, but it was lost for 2,000 years and then rediscovered by Newton. That's another possibility. Because the big fire in the Alexandria around 80 destroyed every knowledge, all the knowledge about math. And then dark age for 2,000 years, and then something like that. So let's say sine x plus delta minus sine x is sine x cosine delta cosine x sine delta minus sine x. So this is sine x square root 1 plus delta square over 1 minus 1 plus cosine x square root of 1 plus delta square over delta. Sine x square root of 1 plus delta square 1 minus 1 plus delta square over 2 cosine x delta over square root of 1 plus delta square. Maybe I should copy. And move to next page. Paste. Sin x times 1 plus delta square minus delta square over 2 plus cosine x delta square. So you divide by this. If you divide by sine x plus delta minus sine x is sine x times 1 plus delta square minus delta over 2 plus cosine x times 1 over square root of delta square. So what happens if you set delta is equal to 0? Sine x plus delta minus sine x. The first term, when you set delta equal to 0, this term moves to 0, right? This term. Right? And all these terms survive. So this becomes cosine x. Therefore, dx sine x is cosine x. Of course, I think you memorized this when you learn this. 고등학생이 외웠지. But actually, you can derive using Newton's formula. Cosine x, same. Probably show maybe I can leave a homework. Composite function. For example, f of gx. Then dx d f of gx is dg df dx dg. You probably learned in freshman calculus, right? Chain rule. Let's say g x plus delta as gx plus delta g, and as delta goes to 0, we have delta g goes to 0. So f gx plus delta minus f gx over delta is actually delta f g plus delta g minus f g, which can say delta G f G plus delta G minus f G delta over delta G. And delta G, Gx plus delta minus Gx, right? Therefore, it becomes as delta goes to 0, delta G goes to 0, it becomes dg df dx dg. So for example, if we have a training. So if we have 1 over cosine x, what do we get? Copy this result. For example, when fx is 1 over cosine x, and let's say gx is cosine x, then so fx is 1 over g, right? What happens? dg df is minus 1 over g squared, right? And dx dg minus sine x, right? So dx dfx is minus g squared times minus sine x is cosine square x sine x. Also, we have the following formula. If an fx is gx hx, then dx dgf is dx dg hx plus g dx dh. I think you also have this formula too. So using this formula, we can actually calculate the tangent x, differentiation of tangent x. So dx d tangent x is dx d sine x over cosine x is dx d 1 over cosine x plus times sine x plus dx d sine x 1 over cosine x. And we just did that, so this is cosine square x sine x times sine x plus this is cosine x 1 over cosine x is equal to 1. So it becomes 1 plus cosine square x sine square x is actually 1 over cosine square x. It's called secant square x. Of course, you memorized this in high school too, right? So after trigonometry function, what else? Exponential and logarithmic. Or maybe you can do that next week after the class, after the quiz. So let's stop here today and continue next week. So good.